Hi, I'm Samantha, and this is my video project for the FRQ problem. I'm going to be going over question 6 of the 2012 AP Calc AB FRQ. The question states for the interval 0 to 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals cosine pi over 6t. The particle is at position x equals -2 at time t equals 0. So we're going to be using that basic information to solve the next 4 parts of the question. So let's move on to part A of the problem. Part A states that for the interval 0 to 12, when is the particle moving left? So when the particle is moving left, this basically means that v of t is negative because the particle is moving along the x-axis. So what we need to find out is when v of t is negative, and we do this using the first derivative test. If you remember, the first derivative test is basically setting the first derivative equal to 0 to find critical numbers, then using those critical numbers to set up intervals and find out when the first derivative is negative and when it's positive. So we're going to be looking for the interval when v of t is negative. So when we set cosine pi over 6t equal to 0, which is the function v of t, that's sort of hard to solve because pi over 6t is not a simple number. So to make it easier to solve, we're going to create a variable x, which is going to be equal to pi over 6t. It's sort of similar to u substitution, I guess. So when we get cosine of x equals 0, we find that at pi over 2 plus pi over 2n, cosine of x will equal to 0. If you look at the graph up there, it'll be the x value will be 0, and that's going to be when cosine of x equals 0. So when we set pi over 2, 3 pi over 2, 5 pi over 2, etc. equal to pi over 6t, which was what we set x equal to, we get t equals 3, t equals 9, and t equals 15. However, t equals 15 is out of the interval, so we know that any value above 5 pi over 2 is not going to be taken into account. So the only t's we're going to be taking into account are the ones between 0 and 12, and those are 3 and 9. So we're going to be setting up our intervals based on those values. So down by the chart, we see that our intervals will be 0 to 3, 3 to 9, and 9 to 12. We pick test values in between those intervals, and you really only need to find out which quadrant they're in to figure out whether or not v of t is positive or negative. So for the interval from 0 to 3, we find out that the velocity function is positive because it's in quadrant 1, and then for 3 to 9, we find out that it's in quadrant 2, which means that it's negative, and for 9 to 12, we find out that it's in quadrant 4, which is positive. So really the only interval that the particle is moving left for is the interval from 3 to 9 because v of t is negative. Next, we're going to be going over part B of the problem, which is a fairly short part. It says write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to time t equals 6. The only concept we're really applying here is the difference between distance and displacement. As exemplified by those two little pictures, displacement is the total distance traveled from point A to point B. And distance is does take into account the path you take to get from point A to point B. By putting an absolute value sign around v of t, we're taking into account the deconstructive distance that we traveled. In other words, if point A to point B is in a positive direction, but we went in a negative direction on the way to get from point A to point B, putting an absolute value sign around the velocity function when you're taking the integral of that is going to take into account the negative distance that you traveled while you were going in a net positive direction. So all you really need to do is write an integral from 0 to 6 and put an absolute value sign around v of t to get the total distance. Next, we're going to be talking about part C. Part C says, find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at t equals 4? So first we're going to find the acceleration function. Acceleration is just the rate of change of velocity. So to do that, we just take the derivative of the velocity function. When we do that, we get negative sine pi over 6t, and then we multiply that by the derivative of the inside. to get negative pi over 6 times sine of pi over 6t. That's the easy part. Now we need to find out whether or not the speed is increasing, decreasing, or neither at t equals 4. So speed is basically the scalar quantity, the scalar counterpart of velocity. If velocity has speed and direction, then speed is basically just the magnitude of velocity. It doesn't matter whether velocity is positive or negative. It just matters what's the number assigned to the velocity. So in order to find out whether or not speed is positive or speed is increasing, decreasing, or neither at t equals 4, we need to find out what's the acceleration at t equals 4 and what is the velocity at t equals 4. If you remember from part A, we found out that from 3 to 9, the velocity is negative. You can use that, or you can just plug in 4 again to find that v of 4 equals negative 1/2, so velocity is negative at t equals 4. Plugging in 4 to our new acceleration function, we find that at t equals 4, acceleration is negative square root of 3 pi over 12, so again, it's negative. So now that we know that velocity and acceleration both have the same sign, we can figure out whether or not it's increasing, decreasing, the speed is increasing, decreasing, or neither. To do this, we just need to think about it conceptually. Because velocity is negative, that means it's going in a negative direction. Because acceleration is negative, this means acceleration is also going in a negative direction. Because both velocity and acceleration have the same sign, this means that the acceleration is making the velocity greater in magnitude. If velocity were positive and acceleration were negative, this would mean that the positive velocity would be getting more negative. The positive velocity would be decreasing. But because they both have the same sign, we can say that the magnitude of the velocity is increasing, and that's the justification we give. We can also think about this graphically by saying that because v of t is negative and decreasing, because the second derivative is negative, if you look at that graph down there, then the magnitude of v of t is increasing. So the answer is that the speed is increasing at t equals 4 because v of 4 and a of 4 are both negative. Next, we're going to be going on to the last part of the problem, part D, which says find the position of the particle at t equals 4. First, it's important to note, going back to the initial information given, that the position at t equals 0 is x equals negative 2. So the initial position is negative 2, and we're going to be needing to add that on to whatever total displacement we find from t equals 0 to t equals 4 to truly take into account where exactly the final position is. So all we really need to apply to this problem, firstly, is that the integral of v of t from 4 to 0 is the displacement that the particle has traveled from 0 to 4. So basically, what's the change in position from 0 to 4? And we're going to need to add that onto the initial position in order to get the total position at the end at t equals 4. So we're going to make a new function. Let's just call it x. So we'll say that x of 4 equals negative 2 plus the integral of v of t from 4 to 0. Notice we don't put the absolute value sign like we did in part B because we're measuring displacement or the change in position and not distance. So when we plug in cosine of pi over 6t for v of t, we need to find the antiderivative of that. When we do that, we get, we would obviously get sine if you remember your derivative formulas, but we're going to need to do a little bit of u substitution in order to do that. So if we do u equals pi over 6t, we get the derivative of u is pi over 6t dt. So we plug that in, and then we get negative 2 plus 6 over pi times the integral of cosine u du. We need to plug in our limits back into the u equation in order to get the correct limits. We get 2/3 pi and 0. Now we need to find the antiderivative of cosine of u, which is just sine of u. After that, we solve through and we get negative 2 plus 6 over pi times sine of 2/3 pi minus sine of 0. Just, you either know those values or you could draw a graph and figure them out. You get negative 2 plus 6 over pi times square root of 3 over 2, because sine of 0 is just 0. And then you get negative 2 plus 6 square root of 3 over 2 pi. Simplifying that down, you get your final answer, which is negative 2 plus 3 square root of 3 over pi. Thanks for watching my video project on question 6 of the 2012 AP Calc AB FRQ. I hope this helped, and good luck on all your future academic endeavors.